Okay, in this video, we're going to introduce what is called the exponential representation of a complex number. So far, what we have seen is the following. So, complex number z can be represented in the form x plus iy, where x and y are real numbers. Then we said this can be plotted on the Argand diagram, where this is going to be equivalent to the point with coordinates x, y. So that means the horizontal side of this triangle is going to be x, and the vertical is going to be y. Then we said using Pythagoras, this we can find as r, which is square root of x squared plus y squared, and this we called the argument. Then we actually showed that from there, then the complex number can be written in the form r cosine theta plus I sine theta. We said this bit can be abbreviated CIS theta, and then we said this is called the polar form of the complex number. This one is the rectangular form. Okay, so that's what we've covered so far. What we're going to do now is we're going to introduce what is called Euler's formula. This is one of the many Euler's formulas that you will meet in advanced mathematics. So Euler's formula relates the exponential function with trigonometric functions. So Euler's formula says e to the I theta is given by cosine theta plus I sine theta. This, of course, is just CIS theta. So using this, we can now rewrite this as just e to the I theta. So this is what our complex number is going to look like now. So z is equal to x plus iy. This is the same as r CIS theta. Now we're going to write this as r e to the I theta. Now this is called the exponential form of the complex number. This is the polar or trigonometric form, and of course this is the rectangular form. So in order for us to go from rectangular to polar, from rectangular to exponential, we need to find r and theta. Okay, we're going to do examples in the next video of how to convert, say, from rectangular to exponential, or from exponential to rectangular. We've already done from rectangular to polar. Okay, so for now, we're just going to notice a few things from the Euler's formula. So we are saying we have got e to the I theta. So so note that since e to the I theta is equal to cosine theta plus I sine theta, or cis theta. Let's call this equation 1. Then if you instead of theta, if we plug in negative theta, so this is going to be cosine negative theta plus I sine negative theta, which is going to be cis negative theta. But then what's going to happen is since cosine is an even function, then cosine negative theta is the same as cosine theta, and since sine is odd, sine negative theta is negative sine theta. So let's call this equation 2. Just going to bring down equation 1 here for convenience. Okay, now so notice now if we add these two, so if we do 1 plus 2, then the sine terms are going to fall off. So we're going to have e to the I theta plus e to the minus I theta is 2 cosine theta. Then from here, if we make cosine theta the subject of the formula, then this gives us a formula that defines cosine in terms of your exponential functions. So cosine theta is e to the I theta plus e to the minus I theta over 2. Then now if we subtract these two, so if we do 1 minus 2, then this time the cosines will cancel out, these will add up. So 1 minus 2 going to give us e to the I theta minus e to the minus I theta. That is going to be 2I sine theta. And then again, if we make a sine theta the subject of the formula, so this time we've got e to the I theta minus e to the minus I theta, all divided by 2I. So that is the corresponding formula for sine. So these two are going to be pretty useful formulas going forward. Just going to extend these. So what these mean is that, for instance, so if you plug in 2 theta here, then that's going to be 2 theta there, 2 theta there. So for instance, so cosine 2 theta is simply going to be e to the 2 I theta plus e to the minus 2 I theta all over 2. And then for cosine 4 theta again, that's going to be 4I theta minus 4I theta. Then similarly, sine 2 theta is going to be e to the 2I theta minus e to the minus 2I theta all over 2I. So just one exercise before we bring this video to an end of how these formulas can be applied. I'm just going to square both sides of this formula number 3. Okay, so from 3, so if we square both sides, the left hand side is going to be cosine theta squared. Okay, and then the right hand side is going to be e to the I theta plus e to the minus I theta all over 2 all squared. Then we're going to expand the right hand side using the binomial. So for the denominator is it's 1 over 2. a number of ways we can do this. Maybe let's do this. Let's write this as e to the I theta over 2 plus e to the minus I theta over 2. So those are our two terms. So by the binomial theorem, this is going to be the first term squared plus 2 times the first term times the second term. So it's I theta over 2 minus I theta over 2, and then the last term is going to be e to the minus I theta over 2 all squared. So all we're doing here is we're using the fact that a plus b squared is equal to a squared 2ab plus b squared. So that's all we're doing there. And then so e to the I theta squared is going to be e to the 2I theta. That's going to be over 4. Then here, this plus this times this is going to, so we're going to get 2e to the 0 over 4, because e to the I theta times e to the minus I theta is e to the 0. And then the last time is going to be e to the minus 2I theta all over 4. Then these two I'm going to bring together. So we're going to have e to the 2I theta plus e to the minus 2I theta all over 4. What I will do is I'll factor out a 2, because we are realizing that that is looking pretty much like this one, but it had over 4, so we factor out 1/2 so that it's over 2. And then this one is just going to be 2 over 4, which is 1/2. So then factoring out 1/2, this is now giving us 1/2 into, this is just cosine 2 theta plus 1. Okay, so this thing is telling us that cosine squared theta is 1/2 plus 1/2 into cosine 2 theta. So this is like one of the double angle formulas which you will be familiar with from trigonometry. Okay, if you do the same thing with this one, okay, just make sure you can do that. Then you find that sine squared theta is 1/2 into cosine 2 theta minus 1 that time. So that is the corresponding formula for sine squared double angle formula. All right, thanks for watching. So in the next video, we're going to now start looking at how to convert from rectangular to polar and vice versa. Sorry, rectangular to exponential and vice versa. And then after that, we'll see how to add, subtract, multiply, divide numbers in exponential form. Thanks for watching. Hopefully it's been useful. If you haven't subscribed, of course, we do encourage you to subscribe to our channel so that you can get notified whenever we post new stuff. If you've got any questions, you can kindly post them in the comment section. Thank you.